Hi everyone, today we'll be looking at the 2H paper of June 18. Question 1, we have to make A the subject of this formula, which means leave A on its own. So we could start off by saying that M plus BD is AC. And then if we just divide everything by C, M plus BD over C is giving us the value of A. So final answer will be A is M plus BD and all of it over C. In B, we need to solve the inequality 5x minus 4 is less than 39. So we start off by saying that 5x is less than 43. So x is less than 43 over 5. There is no need to make this into a decimal, we'll just leave it as it is. That's my final answer for B. And then in C, we need to factorize fully the given expression. We see that 6 is a common factor, E squared and F are also common factors. So I need a 3 and an F squared minus 2E. So 6E squared F brackets 3F squared minus 2E is the answer to C. In 2, we need to work out the difference between the largest share and the smallest share when 3,450 yen are divided in the ratio 2 to 6 to 7. So if we just start off by saying that 2 plus 6 plus 7 is 15, we can conclude that we are splitting 3,450 into 15 equal parts. So this is giving a result of 230, and then the smallest ratio is 2 and the largest is 7. They have a difference of 5, so 5 times 230 is 1150. So that's the difference between the smallest and the largest ratio. 3, someone is paid 20,000 a month and another guy 19,200. They are both given an increase, and after that increase, they are both paid the same amount each month. Gopal was given an increase of 8%. What's the percentage increase of the other guy? So I will start by increasing 20,000 by 8%. So the multiplying factor is 1.08. So if we just do this quickly on the calculator, we get an answer of 21,600. So we can see that the salary of the second person has increased from 19,000 to 21,600. So if we just do 21,600 over 19,200, we will be getting a result of 1.125, which corresponds to a 12.5% increase. So that's 12.5. In 4, we need to show that the given calculation gives a result of 1 and 53 out of 56. We can't really be using a calculator here, so we can start off with 3 and 4 over 7 minus 1 and 5 over 8. I will convert this into equivalent fractions with a common denominator of 56. So 7 goes 8 times into 56, so that's going to be 32 out of 56 minus 135 over 56. So we can borrow 1 from 3, that's 2, and 88 over 56 minus 1 and 35 over 56. And I do the integers with the integers and the fractions with the fractions. That will give me 1 and 53 out of 56 as required. Remember that when you've got show that questions, you actually need to show every single step in order to get full marks. Number 5, we've got P and Q points on a circle centered at O. QT is a tangent. angle OPQ is 18 degrees. We need to work out the size of PQT. Now, there are certain things that are immediately evident. So this is an isosceles triangle, so the angle here must also be 18. We need to give reasons here. So OQP is 18 degrees because of angles at the base of an isosceles triangle being equal. So that's the first reason I'm giving here. And we also know, we've been told that QT is a tangent, which means that the angle here is 90 degrees. So OQT is 90 degrees, and the reason is angle between a tangent and the radius at the point of contact is 90 degrees. So if this is 90 degrees, then we simply know that PQT is 90 minus 18, which is 72 degrees. So that's the answer to question 5 here. 72 degrees, reasons have been provided in order to claim full marks. In 6, we need to work out the curved surface area of cylinder A. So we know that the curved surface area is given by 2 pi RH. So we're just gonna do 2 pi, the radius is 0.56, the height is 1.6. If we plug everything on the calculator, we get 5.63 square meters, rounding our answer to 3SF as instructed. So 5.63 here. Now B is mathematically similar to A, and the height of cylinder B is 0.6. We need to work out the radius of B. So we know that to go from 1.6 to 0.6, we multiply by K. That K is simply 0.6 over 1.6, which works out to be 3 over 8. That's the length scale factor. And we have to find the height of B, the radius of B. So if we've got the radius here, then all we need to do is multiply by K. So I'm just gonna do 0.56 times 3 over 8. So 0.56 times 3 over 8, the length scale factor. And this is giving a result of 0.21, and that's meters. So it's all about the scale factor here. 7, we've got class A and class B, the number of students in each class, and the mean score for all students being 72.6, and the mean score for class A being 75. So we know that to find the mean of class A, we added up all the values. So we can say that 75 times 28 plus the mean of B, I will call this X bar, times 32, over the total number of students, which is 28 plus 32 is 72.6. Now I've got two means, class A and class B, and in order to find the overall mean, I have to weigh by the number of observations in each of those groups. 75 times 28 is 2,100 plus 32x bar over 60 is 72.6. I will cross multiply and rearrange, and I will be getting that 32x bar is 2256, which upon division by 32 is giving me a result of 70.5, and that is the mean for class B, 70.5. Now, we are told that the lowest score in A is 39, the range of scores for A is 57, and correspondingly, lowest score in B is 33 and range in B is 60. Find the range of scores for all the students in both classes. So, we know that for class A, the lowest was 39 and the largest was 39 plus 57. Which is equal to 96, And for B, the lowest is 33 and the highest is 33 plus 60, which is 93. Now, if I consider A and B together as one sample, then we can see that the lowest we can go is 33 and the largest is 96. So the range will be 96 minus 33, which is 63. So that's the range for the combined classes. In 8, we've got a right angle triangle, which we need to work on to determine the value of x. We see that we've got angle here, the 52, so we've got the adjacent, we're looking for the hypotenuse. I will be using cosine. Cosine of 52 is 12.6 over x. So x cos 52 is 12.6, which leads to 12.6 over cos 52. And this is giving an answer of 20.5 to 3SF. In 9, we've got simultaneous equations. I could actually use elimination here. I will take the first one here and multiply it by 5, because that will give me 5y. So 5x plus 5y is 75. And then I've got 7x minus 5y is 3. So if I add them up, I get 12x is 78. So that allows me to determine the value of x, which turns out to be 6.5. And I'm not done, I need to find y as well. So if I substitute into this first equation, we get that 6.5 plus y is 15. So y is 8.5. So we'll just write the answers here. Remember that for simultaneous equations, we need to be getting both the value of x and y. In 10, we need to find the value of n for this expression here. Now, notice that we can write a as 2 to the power of 3 over 2 to the power of 7 is 2 to the power of n. And when we've got division with a common base, we subtract the powers. So 2 to the 3 minus 7 is 2 to the n, so minus 4 is n. So the value of n is minus 4. Now for part B, we need to bear in mind that raising a power to a power means multiplying the indices together. So we've got 13 to the minus 24 times 13 to the 5 is 13 to the k. And when we've got multiplication with a common base, we add the indices. So it's minus 24 plus 5, which is minus 19, and therefore k is minus 19. In 11, we've got a solid metal sphere with a radius of 1.5 centimeters. The mass of the sphere is 109.6 grams. We need to work out the density to 3 SF. Notice that they expect answers to grams per cubic centimeters, so no need to worry about converting units. We are told in the formula booklet that the volume of a sphere is 4 over 3 pi r cubed, which in our case is 4 over 3 pi times 1.5 to the power of 3. So if we just do this on the calculator without the pi, I get 9 over 2 pi. And we've got the mass, and we know that density is mass over volume, and the mass is 109.6 over 9 over 2 pi. So if we plug this on the calculator, we get an answer of 7.75 grams per cubic centimeter. So that's the answer we got here. And we're moving on to 12. We've got the diagram here showing a polygon. It's a hexagon. BC is parallel to ED. We need to work out the size of the obtuse angle DEF. Obtuse means more than 90. So we have to be careful here which angle we refer to. It's a hexagon, and we've got also the parallel lines. So I can start off by considering this angle here, theta, angle CDE, and we can say that theta is 180 minus 42, which gives me a result of 138. So the reason is that it's interior angles, but we haven't been asked to give reasons, so I'm not going to bother writing out interior angles. But now that we know this angle here, then we are essentially looking at a hexagon with 1, 2, 3, 4, 5 angles known. We know that the sum of interior angles in a polygon is just n minus 2 times 180, where n is the number of sides. So in our case, 6 minus 2 times 180, which is 720. So to find the angle here, I'm just gonna do 720 minus 50 plus 96 plus 144 plus 42 plus 138. So if we quickly do the calculation here, we should be getting a result of 250 degrees, and this is the angle here, 250 degrees, which means that what we have to find here, which is the obtuse angle between 90 and 180, is just 360 minus 250 angles at a point, add up to 360, which is 110 degrees. And that should be our final answer, 110. Question 13, probability question. We've got the tree diagram there, so we need to read the question carefully. We have 10 cards, 5 red, 4 blue, 1 green. Felix is taking one at random, does not replace, and then takes a second one. We need to be considering what's happening. If the first one was a red one, it means that we are now looking at 9 cards, 4 of which are red, 4 over 9. The blue are still 4, and that green one is still there. Notice that the probabilities should all be adding to 1 here. Now, if instead the first one was a blue one, I'm still having 5 reds out of a total of 9 cards now, but the blues have gone down by 1 into 3 over 9, and the green is just 1 over 9. Notice that I do not simplify fractions, I leave them as they stand, so that the denominator also represents the number of objects, the number of cards remaining. And finally, if the green one was drawn out, then we still have the 5 red cards, the 4 blue cards, and 0 out of 9 for green, because there are no green cards left. Now, what's the probability that Felix will take at least one blue card and no green? So, at least one blue and no green. I will be ticking those combinations that are successful for us. At least a blue and no green. At least a blue and no green. This one as well. The blue-green is not good enough because even though it has a blue, it also has a green. And we don't want anything from this part here. So we only have 5/10 times 4/9, 4/10 times 3/9, and 4/10 times 1/9. Remember that with tree diagrams, I multiply the probabilities through the branches that we travel, and then we add the three different combinations. So it's gonna be 5/10 times 4/9 plus 4/9 times 5/9 plus 4/9 times 3/9, and this is giving a result of 52/90. I have a small mistake here, it's over 10, the first row, because we start off with 10 cards. So 52/90 is the final answer for this question. In 14, we are given a table of values, and we are asked to complete the table. We can use the calculator essentially to reproduce the whole table in one go, which will allow us to check that everything is there by comparing with the given answers and also fill in the missing numbers. So I'll go from -2 up to 3, and for step we put 0.5. So at the -2 it's a -6, at the -1 it's 4, the other two values are filled in, at 1 it's 0, at 2 it's -2, and at 3 it's 4. We need to draw the graph here, so -2, -6, we've got the -1, 4. We have -0.5, 4.875. So -0.5, 4. This is 5 here. So I'm just gonna stay a bit behind the 5 mark. We then have the 0, 4 and the 1, 0. And we then have 1.5 minus 1.625, which is somewhere there. And then 2 minus 2 and 3, 4. The aim is to join this with a smooth line, as smooth as it gets. So maybe something like this. And I will continue this. It's a cubic, that's the graph we were expecting. So this is what we get here. We've drawn the graph, and by drawing a suitable straight line on the grid, we need to find estimates for the solutions of the equation x cubed minus 2x squared minus x plus 1 is 0. So we are not allowed to use algebra here, but what we have to do is use the existing graph. So we need to solve x cubed minus 2x squared minus x plus 1 is 0. And somehow we need to make use of the graph drawn, which has equation x cubed minus 2x squared minus 3x plus 4. So in order to go from the top to the bottom, I see that I've got the same number of x cubed, the same number of x squared, that's good. To go from minus x to minus 3x, I need to deduct 2x. And to go from 1 to 4, I need to add 3. So this is essentially a rearrangement, because all of this now is just y. So we need to draw the line y is minus 2x plus 3. So to draw the line y is minus 2x plus 3, I certainly know that when x is 0, y is 3. And we also know that when x is minus 2, y is 7. So I need 2 points to generate 2 points on the graph. So negative 2, 7. Negative 2, 7 is here. And the other one was 0, 3. 0, 3 is here. I will join them with a straight line, and the intersection points will be the solutions to the equation. So we can quickly read off values here. So we've got one there and another one here, and the final one over here. 3 cuts in total. We can read off the values. It's minus 0.5, 6, 7, 8. So minus 0.8, and then it's 0.5, and then it's 2.3 to 2.4. I'm just gonna say 2.4. They are accepting a range of values because it depends on your graph and how smoothly you've joined the points together. Anything sensible will qualify for full marks. So minus 0.8, 0.5, and 2.4. So the mark scheme is accepting a range of values here. Now 15, we've got E and F given to 2 dPs. We need to work out the lower bound for E minus F. Now the E, which is 8.31 to 2 dPs, is between 8.315 and 8.305, whereas F, which is 0.65, is between 0.655 and 0.645. We need to find the minimum value of the difference, so I'm gonna make E as small as possible and F as large as possible in order to minimize the difference. So I will take the lower bound of E, which is 8.305, and the upper bound of F, which is 0.655, and this is giving a result of 7.65. In 16, we are told that R is proportional to T squared, and we need to find a formula for R in terms of T. Now, R being proportional to T squared means we can write it like that, and by introducing a constant of proportionality, we can convert that into an equation. R is KT squared. Now, this is not enough. We need to find K. I can just pick a point. I see this point here. We pass through 210, which means that when T is 2, capital R is 10. So I'll be using this point to find the value of K. 10 is K times 2 squared. So it turns out that K is 10 over 4, which is simply 2.5. And I will only be scoring full marks if I write down that R is 2.5 T squared. So that will be the answer to the first part of the question. And then, given also that R is 8 over 5x, show that T is inversely proportional to root x for T greater than 0. So, we know that R is 2.5 T squared. And we also know that R is 8 over 5x. So, I'm just going to concentrate on the relationship between T and x here to say that 5t squared over 2 is 8 over 5x. So if I cross multiply, I'm getting that t squared is 16 over 25x. So t is the square root of 16 over 25x, which is 4 over 5 root x. Now, when I took the square root, I didn't have to bother about the plus minus because I was told that t only attains positive values. Now, the fact that we have t being equal to a constant over root x means that t is inversely proportional to root x. So we need to state that. Hence, t is inversely proportional to root x as required. Remember that because the question was a show that I always need a conclusion in order to obtain full marks. In 17, we're given y is x cubed minus 2x squared plus 15 minus 15x plus 5, and we need to find dy dx. So we're just using differentiation here. We get the power down, deducting 1 from the power, and we'll get 3x squared minus 4x minus 15, sorry. Now c is the curve with that equation. We need to work out the range of values of x for which we have a negative gradient. In other words, we need to solve dy dx being negative. So this is essentially asking us to solve a quadratic inequality. Now this will factorize into 3x and x, and we could put here the 3 and the 5, so minus 3 and plus 5. So we get critical values to be the negative 5 over 3 and the 3. So if we just draw a number line at minus 5 over 3 and 3, it's a smiley parabola looking something like this. So we've got plus, minus, plus, and we want to be negative overall. So this means that we want the x to be between minus 5 over 3 and 3. The boundaries are excluded because we want a strictly negative gradient. In 18, we've been given that there's a triangle with sides 8, 10, and 14, and we need to work out the size of the largest angle of this triangle. So we can start off by actually drawing a triangle, and it's not a right angle triangle. We have no clue on what it looks like, but we know that this is 8, this is 10, this is 14. Now, it is a fact that the largest angle will be found opposite the largest opening. So the largest side is 14. So the largest angle is here. We want to find theta. So we're just going to use a cosine rule here to determine theta. So 14 squared is 8 squared plus 10 squared minus 2 times 8 times 10 cos theta. So we know that 14 squared is 196 equals to 64 plus 100 minus, now 2 times 8 times 10 is 160 cos theta. So 160 cos theta is 164 minus 196, and this leads to cos theta is minus 32 over 160. If we just do shift cos of that, we get that theta is 101.5 degrees. So that's the largest of the three angles. 19 is a 3D trigonometric question. We're being given a triangular prism with all the measurements shown here. Now FAB and ADC are both right angles. We need to work out the size of the angle between the line BE, this is BE here, and the plane ABCD. We really need to extract the a right angle triangle that will give us the angle here. So if I just join D with B, this is a 90-degree angle here, and we're after theta. Now, we already know that ED is simply gonna be 10 centimeters. And now we also need to find DB, for which I can use Pythagoras theorem here. So to find DB, I'm just gonna do 8 squared plus 24 squared square root. So if we just plug this on the calculator, we're getting a result of 8 root 10. 8 root 10 is the length of DB. And I will now just draw the triangle here. So this is D, this is B, this is E. Now this is 10, this is 8 root 10, D is a right angle, and we are after theta. So we know that tan theta is 10 over 8 root 10. So if I just do shift tan of that, we should be getting an answer of 21.6 degrees, which is the angle we were after. 21.6 degrees is the angle to the nearest decimal place, so 21.6. In 20, it's a histogram. We know that in histograms, it's the area that matters. We are told that 6 of these babies have a birth weight between 2.5 kilos, which are less than 2.5 kilos or greater than 4 kilos. So less than 2.5 kilos is this part here, and greater than 4 kilos is this part here. I'm just gonna concentrate on the small squares. I've got 5 times 4. It's 20 small squares over on the left hand side, and then 10 times 1, it's 10 small squares on the right hand side. So we know that 30 squares are representing a frequency of 6 babies. So between 2.5 and 4 kilos, it's all of these. So I need to determine how many small squares I'm dealing with. So I'm essentially looking at 4 rectangles, which I need to count how many small squares each one of them is. So the first one is again 5 times 4, so 20. The second one now, it's gonna be 1, 2, 3, 4 times 10, 20. So it's 4 times 20, it's 80. And the one immediately after it is 2 as a width times 10, 20, 25. So 2 times 25 is 50. And then the last one, it's gonna be 4 in the width, and then 5, 10, 15. 4 times 15, which is 60. I'm just counting the small squares here. So all of the area I'm trying to calculate is consisting of 20 plus 80, 100, plus 50, 150, plus 60, 210 squares. And we wish to determine how many babies these 210 squares represent. So I'm just gonna use cross multiplication, 210 times 6 over 30, which gives an answer of 42 babies. So in a histogram, the area is giving us the frequency, and by just considering ratio and proportion here between area and frequency, we arrive at the answer of 42 babies. In 21, we need to show that root 45 plus root 20 is 5 root 5. Now we know that 45 is 9 times 5, so I will split this into root 9, root 5, and 20 is root 4, root 5. I'm picking out square numbers here because this will give me 3 root 5 plus 2 root 5, which is exactly the 5 root 5 I was asked to show. So 5 root 5 as required. And then in B, we need to essentially rationalize the denominators. I'm just going to multiply by 1 in an intelligent way, root 3 plus 1 over root 3 plus 1. So what we are doing here is that we are mimicking the difference of two squares here. I'm not going to expand in the numerator. I'm just going to leave it as it is, 2 root 3 plus 1 over, and I get 3 plus root 3 minus root 3 minus 1. In the expansion of the denominators, the root 3 with the negative root 3, they go away, and I'm left with 2 brackets root 3 plus 1 over 2, which simplifies out into root 3 plus 1, which matches the form of the answer I was asked to give my final answer in. So that's root 3 plus 1. And C, we need to express x squared plus 6 root 2x minus 1 in the form x plus a squared plus b. We need to show the working clearly. This kind of indicates the completing the square approach. So the only problem is that we've got a root here, which makes things look a bit more complicated. So what we could do is say that x squared plus 6 root 2x minus 1 is 6 plus 3 root 2 all squared. And upon expansion, this is giving me x squared. It's giving me 6 root 2x. It's also giving me the 3 root 2 all squared, which is just 9 times 2, 18. So you know what? I will deduct 18 to balance things out so that all of this is giving me exactly that. And I still have got the minus 1. So this is x plus 3 root 2 all squared minus 19. An alternative approach would be for us to actually take what we are told to show, expand it, and then equate coefficients. So I can equate the 6 root 2x with the 2ax, and then the minus 1 with the a squared plus b. So we have 6 root 2 is 2a, which leads to 3 root 2 being a, and then minus 1 being a squared plus b, but we know that a is 3 root 2, so minus 1 is 18 plus b, which confirms what we have already found before, namely that b is minus 19. We are asked to express this in that form, so I guess it makes sense to have the final answer being x plus 3 root 2 all squared minus 19. So that was question 21. In question 22 here, we're given points A, D, E lying on the circumference, C is lying outside the circle, F is a point of intersection of the two chords within the circle. So we need to find the value of x, which is this distance here. So what I'm thinking of is to start by applying intersecting chord theorems over here. This will allow me to determine the value of the radius r. So if this is r, this is certainly r minus 2. So what I can say is that 7 times 4 is 2 times r minus 2 plus r. So 28 is 4r minus 4, leading to 32 is 4r, and so r is 8. So now that we know that r is 8, I can apply the intersecting chord theorem here. So we know that this is 8, so this is also 8. So starting from the point of intersection of the two chords, it's gonna be 5 times this is equal to this distance times that distance. So let's see, 5 times 5 plus 11 is x times x plus 16. So 5 times 16 is 80, equal to x squared plus 16x. I'm just going to collect everything on the right hand side, leading to x squared plus 16x plus 80, minus 80 being 0. And this will factor out into x plus 20, x minus 4. So x is minus 20 or x is 4. And we're obviously going to be rejecting the negative as this is not a valid value for x. So x is 4. In 23, the sum of the first 48 terms of an arithmetic series is 4 times the sum of the first 36 terms of the same series. We need to find the sum of the first 30 terms. So we are told that S48 is 4 times S36. Now S48 is 48 over 2, 2a plus 48 minus 1d. This is 4 times 36 over 2. And we've got 2a plus 36 minus 1d. So the 48 with the 2 simplified to give me 24. Now the 2 with the 4 leave me a 2 here. So this is leading to 24 brackets 2a plus 47d is equal to 72 brackets 2a plus 35d. The 24 with the 72 simplify out to give me a 3 here, and therefore 2a plus 47d is 6a plus 105d. So all of this is leading into minus 4a is equal to 58d. So minus 2a is 29d. Okay, that's just one relationship. I've got two unknowns. I can't determine a and d. I'm running out of options. So I have to look at the sum of the first 30 terms. So we're looking for S30 here. So S30 will be 30 over 2. And it's going to be 2a plus n minus 1d. So this is 30 over 2. And I've got 2a plus 29d. But wait a minute, 29d, we just found it's minus 2a. So this is 30 over 2 times 2a minus 2a, which is obviously 0. So even though we didn't manage to actually determine the value of a or d, they cancelled out here, and so the result is just a 0. So that was the answer to the final question of this paper. Thank you very much.